You know the Cheshire Cat that fades away and leaves only its grin? In quantum physics, there's a real effect a bit like that. The cat is a particle, and the grin is one of its properties, like spin polarization. With the right setup, the particle seems to go one way while its property shows up on the other. It's called the quantum Cheshire Cat. Here's the quick version. Imagine a river that splits into two channels. I send a kayak downstream, very careful not to splash, barely tell which channel it's in. That's a weak measurement, a featherlight check that doesn't crash the whole experiment. Now I add two checkpoints, where the kayak starts, and the dock, where I'll only count perfect finishes. That start and select finish is called pre-selection post-selection. I run this many times. Most runs don't hit my exact finish, so I toss them out. On the rare ones that do, I look back at the gentle nudges I recorded. The nudges say the kayak tended to be in the left channel, but the flag, the property, like spin, acted as if it traveled the right channel. It's as if the cat went left while the grin went right. This isn't just a story. In labs, neutrons in an interferometer behaved like the mass went one way, the magnetic moment showed up on the other. With light, the photon's path, its polarization seemed to split too. So, did the particle literally tear in two? No. It's about how information shows up when I only peek gently and only keep the runs that end just so. Quantum properties aren't little stickers riding along with the particle. They're relational. What I can say depends on how I set the start, the finish, and how softly I ask in between. The takeaway, in quantum land, where the thing is and where its properties act can come apart under weak, carefully filtered observations. The cat, the grin aren't separate stuff. Just different shadows cast by the same underlying wave when I look in a very particular way. Wild, right? And that's the quantum Cheshire Cat in 2 minutes.